This lecture is going to go over ionic precipitation reactions. And so remember, when we think about reactions, we can classify them generally into three types. We have what are known as ionic precipitation reactions. That's what we're going to be talking about in this lecture. And then later on, we'll talk about acid-base reactions, in particular acid-base neutralizations. And then lastly, we'll talk about oxidation reduction reactions. But first, let's deal with ionic precipitation reactions. And so we can define this as reactions in which two soluble ionic solids react to form an insoluble solid. So let's take a peek about really what we mean by this. And so we're going to start off and think about a solution of barium chloride and sodium sulfate. And one of the first things we should recognize is both of these solutions are ionic, right? A metal and a nonmetal, and a metal and a polyatomic anion, right? So these are both ionic solids. So if we dissolve them in water, aqueous solutions, so these are dissolved in water, we should predict that each of these solutions will conduct electricity, right? We can go back to the chapter on solutions to review this, but we can think about the barium chloride solid. If we dissolve that in water, it's going to form barium 2 plus and 2 Cl minus ions. In solution, and the formation of the ions is what allows it to conduct electricity, right? It's this movement of positive and negative ions in the water that complete our circuit. And sodium sulfate would do the same thing. So sulfate would split into 2 sodium ions and 1 sulfate ion. And this is true of pretty much any ionic solid. We can put it in water, and we're going to sort of separate it into its individual ions. Now, when we think about reactions now, what we're going to do is we're going to mix solutions. So if we take aqueous barium chloride and we take aqueous sodium sulfate and we mix them, what happens? And so what we have to start out is I have the start of a chemical reaction here. So barium chloride plus sodium sulfate, and notice the phase of matter. So these are aqueous. And so what we see in this is both solutions, here's one of them, and here's the other, are completely clear. They're colorless. Both of these ionic solids completely dissolve in water. They are soluble. But when we pour them together and mix them, what we get is, here you can see it pouring in the formation of a white solid. And you can see it more here. If we let this settle, we'd have a bunch of white solid on the bottom. And so the name of this white solid, in this case, or any solid that's formed, is a precipitate. So something in this mixture is insoluble. And so we think about two questions. What is the solid that we formed? And what are the possible products of this? And so we have to go back and think about, well, what did we have? This is all we have to start. This is everything that's in the beaker as described here. And somehow rearranging these atoms leads to a white solid, something that will not dissolve in water. So the question is, what is that? And so for these ionic precipitation reactions, we can always start by thinking about, well, in solution, we know barium chloride split apart and sodium sulfate split apart. So in solution, in this beaker, in this mixture, what we have are two different cations, barium and sodium, and two different anions, chloride and sulfate. And so the solid that we get has to be a combination of a cation and an anion. All right, and so we can think about, it could be barium coming together with chloride, and that would be barium chloride. But we know that barium chloride is soluble because we started with this and it did not form a precipitate. So it can't be barium chloride. It could be sodium sulfate, right? We're just combining cation and anion, but we started with sodium sulfate and we know that was, again, soluble. So all we're doing is sort of saying, what are the combinations of ions that we can form? So we could form our barium and chloride could come together, our sodium and sulfate could come together, or we could start doing cross matches and say barium and sulfate could form together, or sodium and chloride could form together. It's a little messy, so I'll kind of wipe that out. And so we can say in a list form, here are the possible solids. And again, all I did was take the cation and put it with both anions. So barium with chloride, barium chloride, barium with sulfate, barium sulfate, sodium with chloride, sodium chloride, sodium with sulfate, sodium sulfate. One of these four is the precipitate. The question becomes, which one of those four? And so we can start to use some general logic and say it can't be barium chloride and it can't be sodium sulfate because we started with them and they fully dissolved. They were aqueous. So that leaves two possibilities, barium sulfate or sodium chloride. And at this point, we might need some knowledge of either of these compounds to determine which of those is the solid. And what we might know is that sodium chloride here is table salt. This is the salt that you put on your food when you eat. And if you put salt in water, it dissolves. So we might have some knowledge to say sodium chloride is soluble in water. And that means the only option left for a precipitate is barium sulfate. So barium sulfate has to be the solid. So if we go back to the chemical reaction, so we started with barium chloride, aqueous, plus sodium sulfate, aqueous, goes to, and now we know we have barium sulfate solid. And then we have to balance our reaction, so then we also have plus sodium chloride aqueous, because this is going to dissolve. And now watch your stoichiometry, because we had 2 chlorides and 2 sodiums, we actually need 2 sodium chlorides to balance it off. And this would be our balanced ionic precipitation reaction. Now, when we think about this, if we perform this reaction and we mix barium chloride and sodium sulfate to get our precipitate, will this mixture conduct electricity? And when we do this experiment, if we put our light bulb in this mixture, yes, this will conduct electricity. And the question is, why does this conduct electricity? Well, if we think about chemically what's going on, we know both of these would conduct electricity on their own. If we mix them, we're going to get this solid. This is going to fall to the bottom of our flask. So those ions are not going to be able to conduct electricity. But what's left over is sodium chloride. So we still have a bunch of salt in our water, right? And this is what is shown pictorially. Here's your sodium sulfate solid. All right, you can see that here. But what we still have is all of these sodium chloride ions, aqueous, that allow us to conduct electricity. Okay. So the last thing we want to talk about is writing the chemical equation for the formation of barium sulfate. And what we showed was what's known as the molecular equation. And that's what we showed before. So this is just barium chloride aqueous plus sodium sulfate aqueous goes to barium sulfate solid plus sodium chloride solid. The next type of reaction we should be able to write is what's known as the complete ionic equation. And this is the equation that really shows us everything that's going on. So what we're going to do is we're going to write really what exists in the flask. And the key is we're going to split up any ionic solid that is aqueous. So anytime we see an aqueous, aqueous, and aqueous, we're going to write it as it exists in solution. Because we know in solution, barium chloride doesn't exist as BaCl2, it exists as Ba2 plus and 2 Cl minuses. So the complete ionic equation is going to show that, and it's going to look like this. Barium 2 plus 2 Cl minuses plus 2 sodium cations plus a sulfate 2 minus aqueous goes to, notice the barium sulfate is a solid, so that's going to stay the same. And then we have aqueous sodium chloride, so we're going to split that into 2 sodium cations and 2 chloride aqueous. Now, the last thing we can notice in this is when we look at this equation, notice on both sides we have 2 chlorides, 2 chlorides, 2 sodiums, 2 sodiums. So we have the same thing on both sides of our equation. These are called spectator ions, and what that means is they don't actually undergo any change at all. The sodium and the chloride remain exactly the same. So these are not involved in the chemical reaction. They're just kind of floating around in the solution. And so what we can do is write our last form of the equation, which is known as the net ionic equation. And the net ionic equation is only going to show the species involved in the reaction. And so the way you write the net ionic equation is you start with the complete ionic, and then you remove any spectators. So it's going to be the same reaction. We're just going to cross out all of our spectator ions. And so our final reaction equation is barium 2 plus sulfate 2 minus goes to barium sulfate solid. So this is our overall net ionic reaction equation for this chemical reaction. Thank you.